Yes. And we're live. Excellent. First, just a reminder, you do have a homework due tomorrow, 2 o'clock. Expect that to be done. Make sure you follow the instructions. At 11:05 today, there will be a project assigned to you on Google Classroom. The students who are cohort 2 tomorrow, obviously, they're not going to get this lesson until tomorrow, but that project is still going to be assigned to them. The project should be due Friday, not this week, but Friday the following week, October 9th. There is a PDF explaining the project, and there is a video link of me explaining the project in great detail. It's fantastic. You should take a look at that when you get the chance. It's basically what I would have done in class, given the chance I would explain that project, but I don't want to explain it in class considering we don't have much time. So instead, I want to be working on this. Now, for those of you in the chat right now, on Google Classroom, there should be a PDF of this, something that I'm going to be using in class today. I believe I labeled it something to that effect. So if you click on that PDF and open it up, these are the problems that we are going to be working on so that you could see them in great detail rather than me trying to hold up a piece of paper or display something on the front screen. Again, make sure you check that PDF out. Maybe I'll put a reminder into the chat in a little bit. But in the meantime, ladies and gentlemen, this is our focus for today. Now, as a reminder, I can't pass out calculators. But you do have calculators either on your Chromebooks or on your phones and whatnot. So for any of these problems, if you do need to do a quick calculation, by all means, either use the calculator on your phone or the calculator on your Chromebook. That would be phenomenal. But let's get started. I want to do a problem together, and then I want to set you off on a few of these on your own with proper instruction. So let me bring this over to the screen right here. Flip that around. And shapow. There we go. And let me zoom in on problem number 1. Oh, it's frozen like my heart. There we go. So it's going to be a little difficult to see on the front board, which is why I have copies for you all at your desk. And for those of you in the chat, if you can't see it, of course, that PDF is available to you. There's a link in the Google Classroom. But the first problem, a plot of land for sale has a width of X feet and a length that is 8 feet less than its width. A farmer will only purchase the land if it measures 240 square feet. What value of X will cause the farmer to purchase the land? Now, again, I want to reiterate something that I said last week. A problem like this, through sheer guessing and checking, yes, you could get an answer. By sheer guessing and checking, you could figure out what this answer is, but that is not what I want to see. Instead, what I would prefer to see is a quadratic being set up, number 1, and then number 2 being solved by whatever method is available to you. Now, at this moment, the method that you are using is factoring. Factoring. So, I want to set this up with you. Word problems are, I don't know, maybe your worst enemy whenever in regards to math, mainly because people just don't precisely know what to do with them or what to make of them. So, you could do one of a few things, but we have to decipher what this problem is asking us to do. It's talking about a rectangular plot of land. If that's the case, it doesn't actually say rectangular. I do apologize. It should have said rectangular. But length and width, rectangular. We're going to draw this picture out. So on your little piece of paper or whatever you're writing your things on, I would suggest that you write out the image of this shape. Then we need to start labeling some junk. So in order to label this, it says that the width is X and the length is 8 feet less than its width. It tells you the width is X feet. Now, in reality, it doesn't matter the scale. The scale is probably going to be a bit off on this thing. That's okay. But let me label this X right here. Length, width, doesn't matter. One side of it has a length of x. What do I label the side? What do I label the side? It says that the width is x and the length is 8 feet less than the width. X minus a. Now that's going to be incredibly helpful. That is going to be incredibly helpful towards what we have to do with this problem. Eventually, all of these problems are going to produce some form of a quadratic. Some kind of a quadratic that we are eventually going to solve by factoring. Now, for some of these problems, just as a heads up, for some of these problems, you may or may not have enough room to write it on the paper. If you need to kind of transfer that to a separate piece of paper for yourself for later, by all means, do that. I just want to give you the heads up. So for this problem, it says the farmer will only purchase the land if it measures 240 square feet. Square feet is a measure of what? Square feet is a measure of what? It can't be length or width. It's area. And how do you find the area of a rectangle? Yeah. So we have to do that. We have to do that. Area is 240 square feet. We need to measure the area of this rectangle, which is length times width. We need to multiply x times x minus 8. That would give us the area of this rectangle. We set it equal to 240 because that would be the area that the farmer requires. He will only purchase the land if it measures 240 square feet. Ultimately, the question then is asking for you to find x, to solve for x, to get x by itself. This is the setup to this problem. Everything up to this point has been set up. This is the deciphering that you guys are going to have to go through in regards to these word problems. And yes, we are going to get used to these types of word problems. They're always going to be slightly different. No two word problems are going to be the same. No two word problems are going to have the same strategy. I mean, they might, but it's unlikely. So we got to solve this thing. Now, I don't know about you, but I don't see a quadratic up here. Use the orange. There we go. Now, as a reminder, a quadratic should be in the form of ax squared plus bx plus c. A quadratic should be in that form. I can't even see that. Orange is dumb. Orange is a dumb color. There we go. Come on, red. Ax squared plus bx plus c. Much easier to see. Okay. We need to have a quadratic. I don't see a quadratic. Typically, you'll get the quadratic when you begin simplifying this stuff down. When you begin simplifying this stuff down. So, I'm going to have to do that. I'm going to distribute this x. It's going to get me an x squared minus 8x equals 240. Now, again, I may have to put some of this on a separate sheet of paper. Ultimately, in the end. Somebody remind me. Somebody remind me. Now that I have that x squared there, what do I have to do before I continue with factoring? What do I have to do before I continue with factoring? Even before that. I know GCF is the first step. I know GCF is step 1 of the Tucker method. But before I even begin any of the Tucker method, I have to do something else. This is something that you eventually are going to have to do on that project, something you're going to have to remind yourself of. Do you know? You have to get it equal to 0. Ladies and gentlemen, last week I spent a ton of time talking about the necessity of getting things equal to 0. You got to get things equal to 0. Look, you said it right there. Has to be equal to 0. I see you in the chat. Have to get it equal to 0. You have to. You're finding the solutions. You're finding the roots. You're finding the x-intercepts. You're finding the zeros of the function. You have to get it equal to 0. The only way that you're going to use that zero product property is if you get the whole thing equal to 0. That is what you ultimately are going to have to do for all of these problems. Do the setup, find the quadratic, get it equal to 0. Just a matter of x squared minus 8x minus 240 equals 0. I'm subtracting the 240 to get it equal to 0. Let me get the I can get the chat on this thing over here. Here we go. Da-da-da-da. I can bring up the chat on my phone just so I can see it from where I'm sitting. And there it is. Good, good, and good. So now, I got to begin factoring this thing. Now you're talking GCF. She said GCF earlier. The GCF here, well, it's a 1x squared minus 8x minus 240. The GCF is 1. I move on to step 2. Step 2 is A times C. I'm doing a little A times C action. A times C gets me negative 240. I got to find me 2 magic numbers. 2 magic numbers that multiply to negative 240 and add up to negative 8 at the exact same time. Now this, especially for your project, ladies and gentlemen, this is where you're going to have to finesse the problem a little bit. You're going to have to finesse the problem a little bit. And what I mean by that is this. Look, I found 2 numbers that multiply to 240. What's the difference between these two? What's the difference between 10 and 24? 14. What difference do I need? I need 8. So these 2 numbers can't work. All right, let me try it again. I found it. You may not know the numbers off the top of your head, but you could easily just do a little guess and check action in the calculator to find the ones that work. 12 and 20 should work. Which one has to be negative? Oh, I heard 2 different things. You did? Oh my gosh. What'd you say? I couldn't hear it. 12? No. Remember, it's a negative 8, exactly. I heard you say 12. I thought she said 20. Yeah. The 20 has to be negative. The 20 has to be negative because it has to add up to negative 8. So eventually you could do the t-chart, but I'm going to get x minus 20 and x plus 12. This is why a separate sheet of paper may be helpful. I'm going to get 2 solutions. If I set each of those equal to 0, x minus 20 equals 0, and x plus 12 equals 0, if I do that, then I'm going to get answers of positive 20 and negative 12. Positive 20 and negative 12. Now here's my problem. I got 2 answers, but you got a word problem. You got to put it into the context of the problem. The question is, what value of x will cause the farmer to purchase the land? What answer is the only one that could work? Negative 12? So I could have a negative 12 feet. Exactly. That's what I'm saying. The context of the problem. The context of the problem. Because it's a word problems deserve units. And since word problems deserve units, let me move this a little bit. People can see it a little bit better on the thing here. I think it's a little off for the people in the chat. There we go. It's a little better. It's got to be 20 in this case, because what you do in order to check to make sure it works, you plug it back into the original problem. You plug it back into the context of the problem to see if it makes sense. If it makes sense. In this case, you can't have negative 12 feet. It's got to be 20. What value of x will cause the farmer to purchase the land? The value of 20 feet. Yes, it's got to be 20 feet by 12 feet. That's the word problem. X got to be 20 feet. This thing has to be 20 feet. It's the only one that works. Now, we're going to do a little, not trial and error thing here. We're going to do a little thing here. I'm going to set you up for number 2. I'm just going to set you up for number 2, and then I'm going to give you the opportunity to finish it out on your own. I am also going to let you try on your own, not number 3. We're going to do number 3 together, but I'm also going to have you try number 4 on your own. So I'm going to set you up for number 2, and then I'm going to have you try number 4 on your own. So let's see what we got here. I want to set up number 2. Number 2, in business, a break-even point is the point x comma y at which the graphs of the revenue and cost functions intersect. For one manufacturing company, the revenue for producing x items is given by that function, and the cost of producing x items is given by that function. And then they want you to find all break-even points. Now, truth. Give me the truth. Give me the truth. At what word did you stop paying attention to me reading it? No one wants to say? All right. Business. Thank you for being honest. I know what happens. Believe me. You have to be able to decipher a problem. See, the thing is, I've asked students in the past, why do you not like word problems? You know what the number one answer is that people give me? They don't like reading. You like looking at the problem. You like pulling out what numbers you think might be relevant, and then you hope for the best. I know exactly what you guys do. Hold on. Who's in trouble? Okay. Bye-bye. You being signed out? Yeah. Everything's going to be assigned on Google Classroom. Basically, if you go back to the live stream, we're going to go over the rest of this worksheet. Yeah. But I know exactly what you guys do. It's like, equations, hope for the best. No! You got to read the problem. You got to look into the context. You got to see how it's supposed to work together. See? So now, one equation's revenue. One equation's the cost of producing the items. They're talking about a break-even point when the two of them intersect each other, when the two equations are equal to each other. If the cost and the amount of money you bring in are equal to each other, you find what they call a break-even point. That is where I'm going to take this equation and set it equal to this equation. Since they both equal y, since they both equal a y, I am allowed to do that. So now here's what I'm going to allow you to do. Here's what I'm going to allow you to do. That's the help I'm going to give you for now. I want you to finish number 2. You are going to set it equal to 0. You're going to get one side equal to 0. Move everything over to the left. It would be in your best interest to move everything over to the left. And then solve it by factoring. Then, when you are done, I want you working on number 4. You in the chat, I want you doing the same thing. Again, this PDF, the PDF of this worksheet is available to you in Google Classroom. I posted it. The PDF should be right there. Just click on it and you can see the problems. But I'm going to give you a little block of time right now, maybe like 5-ish minutes. I want you to complete number 2, and then I want you to put forth your best effort on number 4. Let's take the time. Let's get it done. Go. those of you in the chat, if you weren't able to find the PDF, I just posted a link. Or if you click that, it should take you to the post that I made with the PDF that you can open. Remember, if you do need to use a quick calculator, by all means, you have them on your phone, you have them on your Chromebooks. You do what you got to do to get that thing done. Find me those magic numbers that make the problem work. All right, let's see what this takes us. I wanted you to definitely complete number 2, and then I wanted you to put forth your best attempt on number 4. But let's talk about number 2. Have I told you guys about the sandbox example? Ever talk about a sandbox? No? When you were a kid, if you walked up to a sandbox and there was a quarter sitting right on top of that sandbox, what would you do? What would you do as a kid? You walk up, you're like a 6-year-old kid. You take the quarter. Why not? Yay, I got a quarter. All right, cool. Awesome. That was easy. The next day, you walk up to that same sandbox. Somebody tells you, hey, there's a quarter buried in the sandbox. It's buried in there. You can't see it. Let's say they're telling the truth. So you walk up to that sandbox and you say, okay, I'm going to find this quarter. Ready? Here I go. I'm going to find this quarter. Here we go. I couldn't find it. I couldn't get the quarter. What did I do wrong? What did I do wrong? Yeah. No, I tried. Look, I'll try again. I tried really hard. I really did. Hey. Oh, what's up? A picture of what?
Am I interrupted?
Yes.
Can we take a quick picture, like for your book of you talking through your microphone?
No.
No. Okay, see you later.
Bye. I always refuse pictures. Why can't I find the quarter? She says I didn't try. I tried. What do you mean? I got to do what? I got to dig in the sand. You're telling me I got to get my hands dirty? Oh. See, most high school math students, they look at a problem and they hope, okay, if I stare at it long enough, eventually I'll figure it out. You got to get your hands dirty. You cannot just figure out most problems just by staring at them. Most of the answers are not just going to be a quarter sitting on top of that sand. You have to dig. You got to get your hands dirty, ladies and gentlemen. Say what? Good question. Does a kid think about that when they're digging for a quarter? Do they think about, am I doing this right? No. See, the thing is, as a high school math student, you remember, like, I don't know what to do. Just start manipulating stuff. Move some stuff around. See what happens. That's the biggest thing that most high school students are not comfortable with doing. They're not comfortable with, like, what do I do now? Well, I gave you the suggestion. Remember, we got to get one side. We got to get one side to 0. Just see what happens. If I get one side equal to 0. By the way, I'm everything I'm writing right now, I'm going to erase just because I'm writing this in marker. I'm going to add x squared over here. I'm going to subtract 10x from right here. I'm going to subtract 5 from over here. That's going to give me an x squared minus 8x plus 7 equals 0. Got to get one side equal to 0. I would suggest make sure the x squared is positive. Whatever the ax squared is, make sure it's positive. That is my resulting quadratic. So I'm going to go about factoring this thing. A times c is 7. Ooh, 2 magic numbers that multiply to 7, but add up to -8? They both got to be negative. Yeah. They both got to be negative. You could do a t-chart if you wanted to. Although since it's a 1x squared, you do 1x and 1x. Get x minus 1 and x minus 7 equals 0. That's where you set each of these equal to 0 and you solve. You end up with x equals 1 and x equals 7. Now, pay very close attention to this problem and pay very close attention to my next question. Which of the 2 answers works? Which of the 2 answers works? But Mr. Markey, they're both positive numbers. I know. Which one works? Here's a curveball for you all. They both do. It's a word problem, but they both work. See, the thing is, they wanted to know, okay, a break-even point is x comma y. Take that 1, and plug it in right here. If I can actually get this marker on. There we go. Y equals 2x plus 12. That's where I got that from. Plug the 1 in right here. y equals 2 times 1 plus 12. What do you get when you plug the 1 in? What do you get right here when you plug that 1 in? Come on, PEMDAS students. It's just 2 times 1 plus 12. I hear crickets. I stepped on one last night. They look really weird and disgusting. It's not a trick question. It's 14. 2 times 1 plus 12. It's 14. This is the ordered pair 1 comma 14. Then if I do the same thing with 7, I get 14 plus 12, which is what, 26? Yeah, 14 plus 12. Both of these ordered pairs work. Look back at the problem. In business, a break-even point is the point at which the graphs of the revenue and cost function intersect. Okay, I don't care about graphs, but revenue is that y equals 2x plus 12. Producing is that quadratic. Find all the break-even points. There were 2 break-even points. People hate word problems. Do you ever hear the word problem of like the guy trying to fit watermelons in the trunk of his car? You know what I'm talking about? There's like these stupid memes online about that kind of stuff. But in reality, it's not about a real life application. It's not about a real life application of figuring out how much junk you can fit in the trunk of your car. That doesn't matter. What matters is the problem solving skills. Not what, Ms. Markey, I'm never going to have to do a break-even point for a business. I know that. But being able to look at a problem, decipher what it's saying, come up with an action plan as to how to solve that problem, and then executing it to see if it works, that's life. Well, taxes are one thing. I just use TurboTax. But I'm just saying, problem-solving skills. I'm not even talking about taxes. I'm just talking about problem-solving skills. Being able to face a problem, identify what you could do to solve it, executing that, and then seeing if it works, and then looking at the results and evaluating it from there. That is life. I'm not talking about math at that moment. Mathematics is the only subject, I repeat, the only subject to help you refine your problem-solving skills. That's it. There's no other subject that's worth it. 2,000 years ago, math was the only subject that they taught. The only subject. Because it was the only subject worth teaching. I'm looking at number 4. After we do number 4, I'm going to go over a couple with you again, and then we're going to do this experiment again with you working on your own. If the measure of one side of a square, hold on, time out. I'm going to draw a square. Cool. If the measure of one side of a square, wait a minute, what's true about all 4 sides of a square? They're all the same. Now, I could label that maybe like x, 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 and x, but let's just leave that aside for a moment. If the measure of one side of a square is increased by 2 centimeters, and the measure of the adjacent side is decreased by 2 centimeters, the area of the resulting is 32 square centimeters. Ooh, interesting. So this side is increased by 2. This side is decreased by 2. And the resulting area of that decrease is 32. Area is just length times width. So I just got to multiply x plus 2 times x minus 2 and set it equal to 32. This is the proper setup to the problem. This is the proper setup. I haven't done any of the math yet. This is just the setup to get there. This one's a little bit more straightforward than the break-even point problem. I don't see a quadratic quite yet. I'm going to have to multiply some junk together. I don't know. What can I do to multiply this junk together? What's that thing that hurts your teeth when you chew it? You don't know? You ever try to chew tinfoil? It hurts. You ever use foil to multiply these together? Nobody? First, outer, inner, last? Oh, okay, that's fine. I don't have to. I can do this. X, -2, X, +2. You can just multiply them like that if you want to. It's perfectly acceptable. I'm going to get an x squared. I'm going to get a -2x. I'm going to get a 2x. And I'm going to get a -4. Now, what's really interesting about this is if I do this particular part, combine like terms, I end up with x squared. Wait a minute. What happens here? What happens with this -2x and this +2x? What do they do to each other? I hear more crickets. You know, there's a lifespan on a question that a teacher asks. If the teacher asks the question and somebody answers it within 5 seconds or so, that's perfectly acceptable. But then if a teacher asks a question and 10 seconds go by, all of a sudden it's even if you know the answer, everyone kind of has this understanding of, ooh, it's way too awkward now to answer. You know, right? And then it gets to 15 seconds and the teacher's still standing up there like a schmuck. And they're like, It's just so funny. Tell me, what happens when you have -2x and you add 2x to it? What do they do to each other? They cancel each other out, yeah. So we're just left with x squared minus 4 equals 32. There's no b value. There's no b value. That's okay. We'll figure this junk out. There's no b value. I got to get one side equal to 0. I got to get one side equal to 0. So I subtract the 32. But I can still continue with the Tucker method. The b value is 0. Even though the b value is 0, I can still continue this thing in the best way possible. See, because if I did a times c, I would get -36. And I would have to find two magic numbers that multiply to -36, but also add up to 0. And after a little bit of thinking, you'd eventually realize that it has to be x minus 6, x plus 6 equals 0 with the advent of the Tucker method. From there, you get two answers. You get an answer of +6 and -6. But those answers one of them is not going to work. Let's try this out. Clearly, at this point, you should realize that the +6 is the answer that you're looking for. 6 plus 2 is 8. 6 minus 2 is 4. 8 times 4 is 32. It works. 8 times 4 is 32. But look at the question. The question is not asking for 8 times 4 equals 32. The question says, find the measure of one side of the original figure, the square. That answer has to be 6. It has to be 6. When you get an answer, you go back to the word problem. This is strategy for all of you. The strategy is when you get your answer, go back to the original problem and see if the answer that you found works in the context of the problem. I got an answer of 6. Okay. The measure of one side of the square is increased by 2. Oh, right, yes, 6 plus 2. It was increased by 2. The other side, 6 minus 2, was decreased by 2, and the resulting was 32. But if it was originally a 6 by 6, then yes, that's got to be the measure of one side. The answer to this problem is 6, but it's 6 what? 6 what? 6 what? A word problem. We need units. We need a metric system unit here. Centimeters, yeah. We need proper units, of course, on the problem. It's got to be centimeters in this case, yes. Centimeters. Oh, I love word problems. Okay, let's talk about number 3. Now, I'm going to go over number 3 with you step by step because number 3 is actually quite interesting. Number 3 is a bit of a doozy. It's interesting, but I like it. Here we go. Zooming in, zooming in, zooming in. Boom. Find 2 consecutive positive integers such that the square of the first decreased by 17 equals 4 times the second. It's a short problem. It's a confusing problem. Slightly painful. I don't know. Think about getting like a flu shot. That's the amount of pain that you would feel about this problem. It's like the equivalent of getting a flu shot. We need to take it piece by piece. The problem-solving skills that you guys have has to be applied to this problem. There are 2 unknowns. The 2 integers that they are questioning us about. Find 2 consecutive positive integers. Don't worry about the positive for now. Don't worry about the positive. Just worry about the 2 consecutive integers. Here is a strategy. The strategy that you can employ is this. Call the 2 consecutive integers x and x plus 1. Do not call them x and y. The reason being is because they tell me they're 2 consecutive integers, meaning one has to be one larger than the next. If I identify my 2 unknowns in that way, now all of a sudden the rest of the problem makes a tiny bit more sense. Such that the square of the first decreased by 17. The square of the first decreased by 17 equals the square of the first decreased by 17. Just taking a word problem and putting it into a literal thing. Equals, just literally an equal sign, 4 times the second. That's how I would set this problem up. That is the pure setup to this problem. That is the pure setup to this problem. It is an amazing problem. All of these problems are amazing, but this is an amazing problem. Taking a word problem, being able to decipher the words in such a way using the variables that we just set up. I got to do a little cleanup here. X squared minus 17 equals 4x plus 4. I had to distribute that other 4, the outside 4. As always, I got to get one side equal to 0. So I am going to subtract the 4x, and I am going to have to subtract the positive 4. Creating something from nothing. I'm going to move that a little bit so you guys can chat, can see this. Move this up here. There we go. They can probably see it a little bit better now. But being able to create something from nothing. Being able to take a pure word problem that just has a few numbers floating around. Being able to identify a couple of variables, x and x plus 1, because they're consecutive numbers. And being able to set up a literal equation. And then all of a sudden that literal equation turns into a quadratic equal to 0. And all of a sudden this quadratic equal to 0 is a problem that we have been working on for 2 weeks. We can solve this. We can solve this. Now I'm going to have to figure out the rest of this on the board. I'm going to move this up a little bit. There we go. Let's get a little green marker action going on here. A times C is negative 21. Ugh. Anybody got magic numbers that work for me? Yeah? Yep. Negative 7, positive 3. Again, T-chart you could do, but you know the T-chart's not really necessary because it's a 1x and a 1x, because it's a 1x squared, which means you get x minus 7 and x plus 3 equals 0. Set them equal to 0 and solve. You get an answer of 7 and negative 3. X is equal to 7, x is equal to negative 3. But again, read the word problem. Find two consecutive what integers? Positive. Two consecutive positive integers. Which means my answer is not negative 3. And my answer is not just 7. They want me to find two consecutive positive integers. It's 7 and what? 7 and what? 8. 7 and 8 are my answers. It's 2/3 of the way towards a hilarious joke. Only 2/3 of the way towards a hilarious joke. You don't get it? You get it? There you go. Say it so they get it. Anyway. But yeah, two consecutive integers. Now, again, negative 3 could work if they allowed negative integers. What is the very next integer after negative 3? Ooh, careful. Notice the direction I went on the number line. What is the number after negative 3? Huh? Go in this direction? Negative 2, right? Yeah, that's weird going in the negative direction, right? Negative 3 and negative 2 technically do work, except they're negatives. And the question wanted positives. They work, 7 and 8. Think about it. 49 minus 17 would give me 32. And then 4 times 8 would give me 32. That works. What a weird problem. Oh, sorry. Okay. Now for a big one. Actually, you know what? No, I'm going to set you up for one, and then we'll do number 5 together. Just as a side note, I'm going to tell you right now, and please mark this down. 7 is an amazing challenge problem. Full disclosure. When it comes to assessments, when it comes to projects, when it comes to things of that nature, I do not put challenge problems on my assessments. I would consider number 7 to be a challenge problem. If you want to give number 7 a shot using factoring quadratics as the way to get the answer, then please by all means do that. But I am not asking you to do number 7 for an assessment. Instead, let's talk about number 6. A rock is thrown. Number 6, a rock is thrown off a cliff. It can be modeled by that equation, where h is the height in feet and t is the time in seconds. How long does it take for the rock to reach the ground? Question. When the rock hits the ground, what is the height? When the rock hits, say again? Yeah. So now that's a key to this problem. Yes, we have to have a quadratic equal to 0. Mr. Mario, that quadratic doesn't have anything equal to 0. Yes, but the logic of the problem is if the rock hits the ground, then it should be equal to 0. So, if the height is 0 equals negative 16t squared plus 8t plus 120. What is this? Haha, that's funny. Cool. Okay. By the way, you all see my T's? You see what I put on my T's? I put a little curly tail on it. You know why I do that? I love putting little curly tails on the bottom of my T's. It's a very logical answer as to why I do that. I don't want to confuse them with plus signs. Keep that in mind. Anywho, I got this as my problem. I got to solve it. All right. Is there a GCF I could take out? There's definitely a GCF I could take out. What value of a GCF could I take out of this problem? They're definitely all divisible by 2, but I think I can go larger. 4, you could definitely divide all of them by 4. But I think I can go larger. It's got to be 8. I'm going to give you a little hint now. A hint, a tip, a trick, a suggestion, something that's going to make your lives 1,000 times easier. Yes, take out the 8, but take out a -8. Here's the reason. If you take out a -8 instead, you are forcing your A value to be positive. If you take out a -8, yes, 8's the greatest common factor, but in this particular problem, trash can. If you take out a -8, watch what happens. This becomes a 2t squared minus t minus, what's 120 divided by 8? What is that? 115? Someone confirm that. 120 divided by 8. Cool. Minus 15. Notice the sign change. The negative 16t squared is now positive. The plus 8t is negative and the plus 120 is negative. You need that to happen. You want your A value to be positive. If your A value is positive, it makes your life a quadrillion times easier. So, I'm going to do a little A times C action here. Within the parentheses, I get -30. I need 2 numbers that multiply to -30 and add up to -1. I need 2 numbers that multiply to -30 and add up to -1. Come on, you got it. It's going to be a 2t and a 2t up here. Oh, no one's got the numbers. They make me sad. Hey, Miss Murray, it's going to be like a 6 and a 5. Yeah, good job. It has to be a 6 and a 5. Yeah, good job. You ever see Castaway? Yeah, I need like a Wilson volleyball in here or something with a bloody handprint on it. Anyway, it's got to be a 6 and a 5. The 6 has to be negative. Those are my 2 magic numbers, -6 and +5. Simplify your t-chart. Let me zoom in and show you how I would simplify the t-chart. If I simplify the t-chart, they're both divisible by 2. This becomes a 1. This becomes a 3. Keep the negative on the bottom. This becomes a t minus 3 and a 2t plus 5 equals 0. We'll move that over just a tad. There we go. Zooming out. Now, here's the key to understanding this. You could solve for t, and you end up with 2 answers. You end up with an answer of +3 and -2.5. You set them each equal to 0 and solve. For the 2t plus 5, you would subtract 5 and then divide by 2. you would subtract 5 and divide by 2. Here's the key to understanding this problem. A rock is thrown off a cliff. It can be modeled by that equation. Let me draw the cliff. Let me draw the cliff here. So here's the cliff. And here's the person. I have amazing drawing skills. And they throw a rock. And the question is, when will it hit the ground? I don't know what the deal is with this cliff, but let's just say the cliff is like a giant rectangle for some reason. I don't really know why. I got 2 answers. I got an answer of positive 3 and negative 2.5. Which one should be the answer? Which one should be the answer? Huh? Positive 3. Positive 3 what? What are my units? Seconds. Yes. Positive 3 seconds. Now for the billion-dollar question. The billion-dollar question. Ladies and gentlemen, the answer is 3 seconds. Yes. And I'm going to write that on my paper. Hold on a tick. I'm going to write that on my paper. Seconds. Where did the negative 2.5 come from? Where does the negative 2.5 seconds factor into this picture? Follow-up question. What shape is this? What shape of a graph is this? What shape does a quadratic produce? It's that P word. It's a parabola. What do you know about parabolas? What shape do they kind of look like? A U. What geometric property? I know I'm bringing you back to geometry a little bit. What geometric property do all parabolas have? Think back to geometry. It's a shape. It's a parabola. It's a U shape. What geometric property do all parabolas have? What happens if you split them right down the middle? What happens if you take a parabola and split it right down the middle? What property of geometry does that kind of show? Starts with an S, ends with an imetry. Oh, no one's going to say it? There's yeah. Now, here's the thing. This is what I'm talking about with word problems, ladies and gentlemen. Word problems have context. Parabolas have symmetry. This is 3 seconds right here. This is negative 2.5 seconds right here. Why do we ignore the negative 2.5? Think about this logically. Logically, in the context of the problem, there's a dude standing on a cliff throwing a rock. Why do we ignore the negative 2.5? Why do we ignore the negative 2.5? What's this kid not going to do with that rock? Say again? Yeah. He's not going to throw it backwards. Dude's throwing it forwards. He's not throwing it back in time. He's throwing it forward in time, which is why the 3 seconds makes all the difference in the world. You have to know when it comes to word problems, ladies and gentlemen. With word problems, you have to look into the context of the problem. The context of the problem means everything. Okay. I'm going to do one little setup for you, but I'm not going to finish it, and then we'll be done for today. I know we skipped over the pool. I know we skipped over the rectangular pool. But there is an example in the video for the project, which talks about that. There's an example in the project which talks about something like that rectangular shape in number 5. So what I want to do is I just want to set this up for you, but I'm not going to finish it. This is not a homework assignment. This is purely a practice if you have the time project. Or assignment, whatever. But I'm not going to be collecting anything for this. I'm not going to be grading anything for this. for number 5. This is purely a practice if you want it kind of situation, which believe me, some of you do. You need the practice. Practice does not make perfect. Practice makes you better. Here's what you're going to draw. A rectangular pool is 20 feet wide, 50 feet long. It's surrounded by a walkway. The walkway is the same width all the way around the pool. I know what the total area of the walkway is. I don't care. But check this out. If you label, oh, that's backwards, whatever. I'll fix it. 50, 20. The dimensions of the pool, if you multiplied those two numbers together, that would give you 1,000 square feet. 1,000 square feet of pool. The idea is that the area of the hole equals the area of the pool plus the area of the walkway. Now, the area of the whole thing, I'll have to figure this out in a moment, but the area of the pool is 1,000. The area of the walkway is 456. Now, the area of the whole thing, this is where the beauty of the magic comes into play. And again, like I said, I'm not going to finish this. If you need a full explanation, there is a different problem. Oh, there's a different problem explained in the video for the project. There it is, it's back. But since the walkway is unknown, you would have to label it as X. And the area of the whole thing is equal to that calculation right there. This is an amazing problem. And like I said, in the explanation of the project, I show you how to do something like this. The video is on the project assignment. I expect that you will be watching that video, explaining how to do the project, and there is an example in that video. It will be assigned to you in the next 30 seconds because Google Classroom has it scheduled to go live at 11:05. These are amazing practice problems. These are amazing strategies that you can utilize for word problems. We're going to continue doing these. I am available on Friday, obviously, with Google Meets if you have any questions, or throughout the week if you want to email me. Make sure you're staying on top of this information, and we'll see you next time because the bell's going to ring nowish. We'll see you goodbye in the chat. Bye-bye. 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 Woo.